Alright, two key ideas in this video, some of which you may already know, but the first one is that if I have any term to the power of 0, that term becomes 1. First thing I want you to know there. The second thing is that if I've got grouping symbols involving a power, well, that means x squared times x squared times x squared, which, as we know, when we multiply, we add our powers. I get x to the 6. Now, the quicker way to go from there to there is to say if I have a power outside my grouping symbols, I just have x to the 2 times 3, which is 6. A little proof of this one as well. I have harped on about all year the fact that if I divide something by itself, I get, you can answer to yourself if you would like, but the answer is 1. Anything divided by itself is 1. So if I have something like x to the 4 divided by x to the 4, well, that's clearly x to the 4 minus 4, that's x to the 0. Now the other way I could write this is x to the 4 over x to the 4, which is x by x over x times x times x times x. Now, each of these will simplify down to 1 over 1. Do the exact same thing. They won't disappear, they'll all become 1s. So I will end up with 1 over 1, which is just 1. So the way to connect those two is that if I have anything with a power of 0, it becomes 1. So a couple of examples of that. If I've got 5x to the 0, all in brackets. Okay, well, we just said we're combining two ideas here. If I've got 5x all to the 0, that means I've got 5 to the 0 times x to the 0. Now, anything to the power of 0 is 1, so that's just 1 times 1, which is 1. That was a little bit different to this one, 5x to the 0. This time, 5 has a power of 1, so this one's actually 5 times x to the 0, which is 5 times 1, which is just 5. So these are two different things, and a common mistake can be to assume they're the same, or assume that the top one has an answer of 5 and the bottom one has an answer of 0. Just because you see a power of 0 doesn't mean the answer will be 1. It just means that anything that has that power of 0 will become 1. What about something like this one? I've got minus 4 to the power of 0. Well, in this case, our answer actually is almost like that. It's got invisible brackets around it. So we end up with, in fact, minus 4 to the power of 0, which is 1. So our answer is just minus 1 there. What about if I've got something like 6x to the 0 minus 2x to the 0? Alrighty, well, this is another one of these type examples where we end up with our 6 having a power of 1 and our 2 having a power of 1, but our x's having powers of 0. So that will actually become 6 times 1 minus 2 times 1. 6 minus 2 is just 4. Again, these parts, but not these ones. The parts I've underlined in red there become 1. The numerals just stay as they are. If we had brackets involved like this top one, it would be a different story, but as it is, our answer is nice and simple, just 4. A couple involving some brackets this time. What if I've got y to the 6 all squared? Could write that out as y to the 6 times y to the 6. Easy way is, though, just y to the power of 12, because I have 6 times 2 is 12. If I've got 3 c squared all to the 5, well, in fact, this time it's actually what we've got is 3 times c squared times c squared times c squared times c squared times c squared. So we end up with 3c to the power of 10. This 3 has a power of 1. You notice I'm harping on about that 1, those ones that are not written there. That's what can cause people to hiccup a little bit. So this part has a power of 5. This does not. Alrighty, what about if I've got something like this, though? Let's bring it inside the brackets this time. Well, this one actually means, if this one is 3 times c squared, c squared, c squared. 5 times this one is 3c squared times 3c squared, so on and so on, 5 times. So actually what it becomes is, this starts with a power of 1 but ends up with a power of 5 times c to the power of 10. Well, we can write that 3 to the power of 5 as a base numeral. 243 c to the power of 10. I hope you can see, depending on how we apply the brackets and whether we include or do not include, that's our two differences there. The numeral inside the brackets, we end up with a pretty different answer. Just one more for you guys. Something a little bit harder, but again, it combines the exact same skills. I've got h to the power of 11 all squared divided by h to the power of 5 all to the power of 4. Alrighty, so the exact same skills apply here. So let's deal with this left to right. I'll start with this one. Well, I've just got a nice h to the 11 all squared, which is h to the power of 11 times 2, 22, divided by h to the power of 5 times 4, which is h to the power of 20. I'm just going to make clear that's a division, not a subtraction. And I end up with h to the power of 2. One very last one here. I've got b squared cubed multiplied by 5, a to the 0 all cubed times ab squared. Going to just gather all that together. Let's go left to right. So b squared all cubed is b to the power of 6 multiplied by 5. Well, this becomes 1. And 1 to the power of 3 is still 1. So I'm just multiplying by 5. This, as I said, this in here all becomes 1. I'll rewrite it there, 1 to the power of 3. 5 does not have a power of 3, it has a power of 1, multiplied by ab squared. So I end up with 5 times a times b to the 6, b squared, which is b to the 8, and then we're done. Nothing more I can do with that one. I have written that incorrectly, that should be an 8. But this is a harder problem. Clearly harder than the first one we introduced, but it's the same idea of those basic skills. You learn those few basic rules. If when we multiply, we add the powers, divide, we subtract. Anything with a power of 0 becomes 1, and if I have brackets, I simply multiply my powers. We end up with a set of skills that will let us solve some harder problems.